All right, so we're here for another installment of People Behind the Science for the Sloan program on microbiology, the built environment. So today we're here with Amy Pruden from Virginia Tech. Thanks for joining us.
Sure.
So can you tell me a little bit about how you became interested in microbiology, the built environment?
Sure. Well, I'm trained as an environmental engineer, and environmental engineers work with all sorts of things: clean air, soil, water, and I became focused on water. Now, my undergraduate degree is in biology, so it was just kind of a natural attraction for me to look at the microbiology of water. And in the past, I'd worked on things like remediation, using beneficial microbes to clean up spills and stuff. And then I started learning about drinking water, and that, you know, I hadn't, even though I'm a microbiologist, even I wasn't aware that there's such a high level of diversity of microbes in drinking water, and that there's like 10 to the 7 or 10 to the 8 bacteria per liter. Even I was surprised by that. And so the other thing I became aware of is that, you know, even though most of these bacteria are harmless, that in developed countries where we've done a really good job of treating water compared to developing countries, it's becoming that the primary source of waterborne disease outbreak are microbes that grow happily in drinking water systems. So they view something like a shower head as like a happy home. And so I became interested in like what could I do about that as both an environmental engineer and as a microbiologist.
Yeah, it's interesting just the number of projects at this meeting that have relevance to people's everyday lives
Right.
that people are studying. So can you tell me a little bit about the new Sloan project that you just got funded?
Sure. So our project is going to focus on the microbiology of the building plumbing microbiome is what we've called it. And so the idea is to characterize the microbes that naturally colonize the plumbing in people's homes and businesses. So we're looking at things like what is the effect of the pipe material, what is the effect of the water chemistry. Like every region in the country is going to have a slightly different water chemistry, and that can have a profound difference on the kinds of microbes found there. And an interesting thing is that our water quality regulations, they tend to focus on the quality of water that comes out of the drinking water treatment plant, and then that is delivered to somebody's property line. And I think we do a pretty good job of that. We've definitely got issues there we have to work on. But there's this issue, like this gap to the tap. So the water that comes out of somebody's tap is a completely different quality than what's delivered to the property line. And it's considered legally, it's the homeowner's responsibility if there are pathogenic organisms growing in their homes. Because it's not the responsibility of the water utility. But at the same time, who's aware of this and what kinds of guidance is there available? So we're hoping through our project just to first begin to understand what kinds of microbes naturally colonize the pipes and fixtures in people's homes. And then in our Sloan grant, we're going to examine very controlled systems where we have replicates of pipe materials, water chemistry, flow rates, and then that can hopefully give some guidance to people. What kinds of pipes are ideal? What kinds of flow regimes? Do you want like a water-saving feature where the flow is low? And this has a lot of implications too as we start moving forward into water sustainability and green buildings, you know, and then this is a very important goal and we have to go after it. But at the same time, we should go after it with our eyes open. You know, a green building has a very different flow regime than a typical building. I mean, the whole idea is to save water. And so that means water is sitting in the pipes longer and there's a lot more potential for microbial growth.
Right.
And I think, you know, if we can get a handle on what kinds of microbes live in building plumbing systems, what are the factors that control those microbes, then we can also get a handle on maybe how to address this issue of waterborne disease outbreak. So things like Legionella, mycobacteria, Pseudomonas, these are things that grow in building plumbing systems, and we don't understand the triggers. And I think if we can dive deep into the microbiome, we'll get some idea into what those triggers are and how we can control them.
Yeah, definitely. And I mean, pipe material must be a big issue because different homes are different ages. And I mean, I live in an apartment and I have no idea what the pipes are made
exactly.
out of. So it's crazy.
Yeah, people aren't thinking about it, but yet it's their legal responsibility.
Yeah, exactly. So how are you getting along so far? Have you collected samples or analyzed any data yet?
Right. So we've officially been Sloan awardees for 18 days, but we are off to a running start. We've been working with Mark Edwards, who's a co-PI on the project, and he has been working in building plumbing systems for years on the water chemistry side, especially things like lead and other contaminants that can get in the water. And so that's been a nice advantage to the project and brings an interdisciplinary angle. And so he's already developed these standardized rigs for doing research on building plumbing systems, because these building plumbing is extremely complex. The pipe material, the flow rates, the water chemistry. Yeah. So it's really important to have replicates and some sort of standardized system. So we have these standardized rigs installed at 5 utilities across the eastern portion of the country. They've already been out there, they've been aged for a year. That's important to get the microbiome established. And so we'll be collecting samples over the next 3 weeks, and they'll be coming in, and we'll start extracting DNA and doing the sequencing on those.
So you're off to a running start already, sounds like.
Yeah.
So what's your favorite aspect or approach to studying the built environment?
Well, I mean, the microbiologist in me, you know, I just think this kind of science needs to be done. We need to know what's out there, what's in the building plumbing systems. That's the front line of microbes that we're being exposed to in our homes, for good or for bad. You know, there's potential, maybe there's some beneficial ones, and I'd like to know about those. But I think going about it in a very systematic and controlled way so that we can get an idea of, you know, what are the factors that trigger the good microbes or bad microbes.
Right, exactly. Cool. And just finally, to finish up, what is one big scientific question in the study of the built environment right now?
I think definitely the issue of what triggers opportunistic pathogen outbreak. So there was an outbreak of Legionnaire's disease at a hotel in Chicago just a couple months ago, and you know, no idea what triggered that. You know, a new hotel in Las Vegas, so it's a brand new plumbing system. It's not like it was deficient. Again, a Legionella outbreak, and so I think a big question is what is it that triggers those kinds of outbreaks?
Well, definitely an important question as well. So thank you for joining us,
Sure.
and stay tuned for more interviews with more people behind the science.